Far beyond the warmth of the sun, in the cold reaches of our solar system, spins a mysterious blue giant, Neptune. As the eighth and farthest planet from the sun, Neptune may seem like a distant outpost, but its vivid blue hues and swirling, stormy atmosphere have long captivated scientists and stargazers alike. Yet beyond its breathtaking beauty lies something far deeper, a cosmic story, billions of years in the making. Neptune isn't just a pretty face in the planetary lineup. It holds vital clues about how our solar system formed, evolved, and continues to change. Understanding Neptune means peering into the ancient past of everything that orbits our star. Around 4.5 billion years ago, long before Earth had oceans or life, our solar system was nothing more than a swirling cloud of gas and dust. From this cosmic chaos under the pull of gravity, the sun ignited at the center, and from the leftovers, the planets began to take shape. According to the widely accepted solar nebula theory, Neptune, like its planetary siblings, was born from this ancient cloud. Tiny particles collided and clumped together, forming larger and larger bodies called planetesimals. Over time, these rocky seeds gathered more material through a process called accretion, slowly growing into what we now recognize as planets. But Neptune's story is a little different. Far from the sun's warmth, in the icy outskirts of the solar nursery, Neptune formed as an ice giant. Its solid core gathered not only gas, but also icy substances like water, methane, and ammonia, elements too volatile to stick around closer to the sun. Because of its distance, Neptune grew more slowly than inner planets like Earth or Mars. But once it reached planetary size, it didn't stay put. Scientists now believe Neptune migrated outward over time, reshaping the edge of the solar system as it went. Its journey likely disrupted countless smaller bodies, helping sculpt the mysterious Kuiper Belt, a region still brimming with frozen relics from the solar system's earliest days. How do you measure the age of a planet you can't even touch? Imagine trying to guess someone's birthday without ever seeing their face, asking their age, or even stepping into the same room. Sounds impossible, right? Yet, that's exactly the puzzle astronomers face with Neptune, an enormous, mysterious world floating nearly 3 billion miles from the sun. We can't land on Neptune. We can't drill into its core or collect rock samples from a surface it doesn't even have. And yet somehow scientists have uncovered its ancient origins. How? By becoming cosmic detectives, experts in a field called cosmochronology, the science of dating celestial objects through indirect but powerful clues. Let's follow the trail. Clues from the sky. Ancient meteorites. The first pieces of the puzzle don't come from Neptune itself, but from deep space rocks that have fallen to Earth. Scattered across deserts and polar ice fields, meteorites hold secrets older than our planet. Some of them are over 4.56 billion years old, formed during the chaotic birth of our solar system. Inside, they contain radioactive elements, natural clocks ticking silently for billions of years. By measuring the decay of these elements, scientists can estimate when the first solid materials formed in the swirling protoplanetary disk. This gives us a reliable timestamp for when planets, including Neptune, began to take shape. It's not a guess. It's science based on the slow, steady heartbeat of the cosmos. Simulating a solar system. The birth of Neptune. Since time travel isn't an option yet, scientists turn to the next best thing: simulations. With supercomputers, they recreate the young solar system, a time when dust and gas danced in gravitational spirals. These simulations show how tiny particles clump together, grow larger, and eventually become full-fledged planets. According to these models, Neptune likely formed within just 10 to 100 million years after the sun was born. That might seem like a long stretch in human years, but in cosmic terms, it's a blink, a sign that Neptune was among the earliest giants to emerge. And these simulations don't just give us a timeline, They explain how Neptune formed so far from the Sun, where raw material was limited. The answers lie in the physics of planet formation, captured in code. Neptune's invisible fingerprints. Even from its distant perch, Neptune has left behind signs of its early existence, etched into the orbits of icy objects far beyond. The Kuiper Belt, a frozen frontier beyond Neptune, is filled with dwarf planets and ancient debris. Many of these objects follow odd, elongated orbits. Their strange movements aren't random. They're echoes of Neptune's gravitational influence over billions of years. By studying these patterns, scientists can reconstruct Neptune's history, how it moved, how it grew, and how long it's been shaping its surroundings. These clues confirm what other methods have already shown. Neptune is ancient, sculpted during the solar system's first act. Why Neptune's age matters more than you might think. Learning when Neptune was born isn't just about filling in dates on a cosmic calendar. It opens the door to a deeper understanding of our place in the universe. The age and formation of Neptune ripple out into several major scientific discoveries and questions. 1. Reconstructing the solar system's timeline. By knowing how old Neptune is, scientists can piece together a more complete story of how our solar system formed. This includes not just when planets appeared, but how they moved, migrated, and reshaped each other's orbits over billions of years. Neptune's age helps build a timeline of celestial choreography. 2. A window into distant worlds. Neptune isn't just a planet, it's a prototype. Astronomers often use it as a reference point when studying similar ice giants outside our solar system, called exoplanets. Understanding Neptune's past gives us a lens to interpret alien worlds light years away, and maybe even how common systems like ours might be in the cosmos. 3. Uncovering inner workings. A planet's age tells us how long it's been cooling, how its internal heat has evolved, and how that affects its atmosphere. Neptune, with its supercharged winds and giant storms, still surprises scientists. Figuring out how old it is helps them decode why its weather is so wild, and what's happening deep beneath those blue clouds. 4. Laying the groundwork for future missions. If we ever send a spacecraft to explore Neptune up close, we'll need all the background we can get. Knowing its formation history helps mission planners target the right questions. What's inside it? How did it form? And how does it compare to the countless other ice giants in the universe? Neptune, the blue giant drifting at the edge of our solar system, is far more than just a distant planet. It's a silent witness to the grand story of planetary formation. Through meteorite analysis, computer simulations, and studies of orbital dynamics, scientists have traced Neptune's birth back to about 4.5 billion years ago. But this discovery isn't just a number, it's a key. A key that unlocks deeper insights into how the universe builds planets, sculpts solar systems, and perhaps even seeds the conditions for life. In Neptune's ancient heart lies not just the story of our own cosmic neighborhood, but clues that echo across the galaxy, reminding us that even the coldest, most distant worlds have something vital to teach us.